Assalamualaikum and hi everyone. This is pre-recorded video 9 for chemical bonding. In previous video, we have discussed the first type of intermolecular forces, which is the London dispersion force or dispersion force. In this video, we are going to learn two more of intermolecular forces. After London dispersion force, another van der Waals forces is dipole-dipole force. It occurred when the molecule is found to have a permanent dipole moment. For example, HCl. You can see the clouds of electrons in Cl is much bigger than H+. There are parts of molecules that is always positive and also always negative. So we call it as permanent dipole moment. This dipole-dipole force is stronger than London dispersion force. The good thing about dipole-dipole force is the dipoles are always there, so that it is stronger than temporary dipoles in London dispersion force. Okay, enough for van der Waals force. Let's move on to hydrogen bond. Hydrogen bond is the attraction force between the positively charged hydrogen and negatively charged atom or another molecule. In this case is nitrogen, oxygen, or fluorine. Hydrogen bond is the strongest of all intermolecular force. Hydrogen is always acted as the positive dipole, while nitrogen, oxygen, or fluorine is always the negative pole. Hydrogen bond is shown as the dotted lines. As mentioned earlier, hydrogen bond is the strongest among all intermolecular forces. However, among hydrogen bond itself, the strongest bond is in this strand. Fluorine is the strongest, followed by oxygen, and then nitrogen. This is an example of hydrogen bond in water. The other molecules that can have hydrogen bonds are water, methyl or ethyl alcohol, HF, and ammonia. In water, the positive dipole of hydrogen always aligns to negative dipole, making water molecules in ice align to form a repeating hexagon, like the one shown in this slide. It takes a lot of energy to make molecules changes its phases. Please take note that molecules of similar molecular weight without the ability to form hydrogen bonds have higher vapor pressure, thus lower the boiling point. Let's take a look at the example here. The molar mass for these three compounds are comparable. However, the boiling point are different because of the presence of hydrogen bonding in H2O, NH3, and CH4. As we can see in the chart of temperature versus period, boiling point is increases in order of ammonia, HF, and H2O, even though supposedly fluorine has the greater electronegativity. Why is this happens? This is because there are 4 hydrogen bonds per H2O molecules compared to only 2 per HF molecule. So it takes more energy to break down hydrogen bond in H2O. That's all the end for intermolecular forces. Thank you. See you in the next video.